So my name is Paige. I work for Microsoft most of these days. I work with partners and customers to bring their solution to Azure and make sure it works well there. In many cases, these partners, they are not traditional Microsoft partners. Oftentimes, they're even competitors. But from cloud perspective, we welcome everyone to our cloud. In fact, one of these partners are with me here, and this is Roger from MariaDB. So the adoption of Azure has really ramped up lately. I'll quickly go through some facts to level set what Azure is and why you might care. And we'll then look at the existing MySQL and MariaDB offerings on Azure. And then we dig into some considerations for high availability and performance. And we'll talk about the reference architecture for various MariaDB and MySQL cluster and their respective deployment methods. So why would you care? Azure has really grown into a credible cloud providers, very few public cloud providers in the world. We have data centers in every part of the world except Africa, and Gartner rated us a leader in pretty much every cloud-related Magic Quadrant, including infrastructure as a service, platform as a service, and cloud storage. But most importantly, customers are coming. So if we look back 5 years ago versus 2 years ago versus 1 year ago, and now, it's a huge difference. It's real. Every once in a while, we're still asked, can someone run Linux in Azure? The answer is absolutely yes. In fact, depending on the workload, whether it's a VM or whether it's a web app or Hadoop, some workload already has the majority running Linux on Azure. We partner with all global ISVs to bring third-party and open-source solutions to Azure. So if you're an enterprise customer, you care about compliance. Azure has one of the largest compliance portfolio in the public cloud industry, including all the major US certifications as well as certifications around the world. So another unique investment we do in Azure is hybrid. So for example, StoreSimple is an appliance that you can put on-prem, and you can configure it such that it will cache hot data on-prem and move cold data to the cloud. Azure Active Directory integrates with your on-premise directory as well as your social identity. Something like over 90% of the enterprises already use Active Directory. So if you use Azure Active Directory, then you don't need to maintain yet another identity system. And we also have this thing called Azure Stack. What it is it's a set of APIs and tools that you can use to build a private cloud in a consistent way that you would use these tools in Azure. ExpressRoute is a dedicated network provided by our telecommunication partners. So you can connect ExpressRoute to your private network without going over the public internet. So if you look at MySQL on Azure, you go to Azure and you search for MySQL. You can see a variety of workloads here, including MariaDB Enterprise cluster and the MySQL-powered web app and WordPress, and also MySQL platform as a service provided by our partner ClearDB. But for the majority of enterprise workload, infrastructure as a service is still the most common option. So if you want to run MariaDB Enterprise cluster or MySQL master slave replication, Percona cluster, you would run all these in infrastructure as a service. When you compare infrastructure service versus platform as a service, they each are associated with pros and cons. The benefit of infrastructure as a service is you can easily lift and shift your on-premise workload, and you can move your workload from cloud to cloud, avoiding vendor locking. The other thing you have over platform as a service is that you have choices in the infrastructure, and you can configure everything operating system and up. So when people move workload from on-premise to cloud, there are two things they care about most: availability and performance. When you think about what's the difference between availability on-premise versus in the cloud, on-premise, first of all, no matter what you do, there are two kinds of outages: unplanned outages and planned outages. So on-premise, you have some control over planned outages. Basically, you can decide when you will do the planned maintenance. You can, in the middle of the maintenance, if something goes wrong, you can decide to stop, or you can decide to roll back. In the cloud, you don't have that kind of control. So you get notifications, and that's about it. So then what you do, you build more replicas, then at what cost? So in Azure, we have several capabilities to help you achieve high availability. At the storage level, by default, every piece of data is replicated 3 times in a single data center. But you can also choose to say, I want to replicate in the same zone, in the same region, but different zones, or in different regions, or even make the replicas readable in other regions. At the compute level, we have this concept of fault domain. So VMs in different fault domains don't share the same power stripe, and they don't share the network switch. And we have the concept of update domain. VMs in different update domains, they don't get updated together. So by placing your VMs in an availability set, you basically spread them out into different fault domains and update domains so that they don't go down together. At the network level, we have public or internal load balancers, meaning load balancers exposed to the internet or not. And each load balancer is, of course, by default, configured to poll each VM agent to see if the VM is healthy. But you can also build your own custom probes to indicate to the load balancer whether your VM is healthy. Traffic Manager is a higher level load balancer. It can route traffic to different URLs based on performance, meaning it always goes to the fastest one, or round robin, or failover, meaning it will always go to a certain one until it fails, and then it goes to the next one. So performance, you also have a few knobs to turn. On-premise, you would buy the biggest machine that fits your workload. In the cloud, you don't have that level of choice, but you have several different VM sizes that you can choose. So some are optimized for compute-intensive workload, some are optimized for I/O-intensive workload. Each VM size decides the number of CPU cores, the amount of memory, network interface cards, and disk size, number of disks you can attach, and so on and so forth. For storage, you also have different types. Standard storage versus premium storage. So standard storage is hard disks, premium storage is SSD. Certainly standard is less expensive, but if you have random reads, random writes, then it's going to be slower because you actually moved ahead. Then you also have ephemeral disks, which are the disks that's attached locally to the VM. These are fastest, but of course, it doesn't survive a host reboot, or if your VM is moved from one host to another. There are several common gotchas on performance when you run something in Azure. If you're running CentOS 7.2 or older, you definitely want to install this thing called the list driver. It solves a lot of performance issues that our customers have seen. Also, if you're running performance tests on standard storage, there's this thing called a warm-up effect. It takes if your disks were idle, it takes 10 to 20 minutes for it to warm up. There's also a concept of storage account. Your disks live in a storage account, but there's a cap on the IOPS of each storage account. So a trick is to spread out your disks into different storage accounts to improve performance. So we have a reference architecture for MariaDB Enterprise cluster and MaxScale. So you can see here, by default, it has 3 MariaDB nodes They're placed inside an availability set to achieve high availability. Of course, because this is a Clara cluster itself also achieves high availability. We also have 2 MaxScale nodes in another availability set behind a load balancer. So anytime one of them goes down, the whole cluster is still going to be healthy. MaxScale, we have 3 services turned on. It can do read-write split so that you avoid multiple writes to the same data record causing conflicts. If different parts of your applications do reads and writes separately, you can connect to different endpoints directly. So read endpoint or write endpoint. It's very efficient. But if your application doesn't do that, MaxScale will automatically split read-writes as well. So we could have just built the template, but we took one step further by partnering with MariaDB to push it onto the marketplace so that you can just go through a UI wizard and quickly deploy a production-grade cluster. So, Roger, do you have anything to add here?
Yeah, I think the key question a lot of people ask is why deploy through Azure? Why deploy through the marketplace? And as Paige was showing you in the reference architecture, you have 5 different instances. You've got 3 MariaDB Clara nodes together in a Clara cluster. And you have an HA pair for MariaDB MaxScale, the dynamic routing platform. You could deploy each of those individually and then spend time basically putting it all together, knitting it all together, doing all the networking, doing everything you need. Instead, as Paige will show you momentarily, through Azure Marketplace and through using the Azure templates, we're able to put all of that together into one pre-configured reference architecture that you can deploy very simply and literally, click the button and deploy within moments. So let me turn it back over to Paige.
So let me just show you quickly how this works. So you go to Azure portal, you find a MariaDB Enterprise cluster, you click Create, and it displays this wizard, and you put in your cluster name, which becomes your endpoint, the database endpoint. You decide where in the world you want to deploy this cluster. Like I said, you can deploy it anywhere in the world other than Africa. You can put in your resource group name, basically putting all these things, the VMs, the network cards, the storage into a resource group. So it's easier to maintain. It's just a logical concept to group your resource. Then you can select your VM size. So these sizes all work well. And then you can decide the disk size as well, anywhere from 128 gig to 1 terabyte. Put in some SSH public key so that you can access your VM through SSH. And then we will put some configuration for the database itself, including the load balancer, whether you want to access it from internet or from inside the virtual network, and your database name, username, password for your database. Now we validate all the inputs, and if everything looks good, you can just click the button to accept the license and go ahead and deploy the cluster. In about 15 minutes, you will get a production quality cluster, all built and configured for you. We also have Percona Extra DB cluster reference architecture. It looks very similar. In fact, we built this one earlier, so at that time there wasn't any premium storage, there wasn't SSD offering. We striped the disks into RAID 0 to improve performance. These days you can use both standard and SSD storage. With this cluster, the template itself is published on GitHub, and we also have a white paper written for it, so you can see some performance results on Percona Extra DB cluster on Azure. So for the traditional master-slave replication, we also have a architecture. As you can see, this also looks very similar. This one is using GTI-based replication, and the the template and the failover instructions are also published on GitHub. So all these templates basically were open source, published on GitHub. So I already mentioned here and there like several different deployment options. To summarize it here, there are several offerings that you can find on Marketplace, which gives you a nice discoverability and nice UI to walk through to provision your cluster. But not every offering is on Marketplace. If they're not on Marketplace, the template is published on Azure GitHub repo. So template, again, is just a JSON file that you use to describe your resources that you need to deploy. And then for each template in our Marketplace repo, there's a visualization tool that you can click on, and it will give you that the picture over there, basically showing you all the resources that you provisioned, and then the relationship between these resources. Another useful thing is that this template works exactly same in Azure as in Azure Stack, which you use to build your private cloud. The other thing is that if you already have a deployment on Azure, you can expose your deployment into a template. So then you can use the template yourself. You don't have to publish it on GitHub. In terms of deployment, so if you don't want to use the UI, you don't even want to go to the GitHub to use the UI, then you can use Linux tools, the cross-platform tools. It works on Linux, Mac, Windows, or on Windows, you can use PowerShell. That's pretty much all I have. Any questions? Everything is clear?
And if you want, you can actually go from MariaDB. We have an evaluation version of this that you can go and launch through the Azure Marketplace and try it yourself.
15 minutes, you will get the cluster up and running.
One thing is try to do that without the Azure template and with the Azure template and see the time difference between the two. It's significant.
And once you're done with it, if you're just playing around before your production deployment, then you can just delete the whole resource group, and everything inside it will be deleted, and you will not be charged. In fact, if you don't want to delete it, you can just shut down the VMs, and you will not be charged. Cool. Thank you very much for coming. I appreciate it. Enjoy the rest of the show.